Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we are going to understand the rules and pseudocode of prefix expression to infix expression conversion using a stack data structure. Now before we start off, we've already discussed the reverse process, that is infix to prefix using stack data structure. We've also talked about infix to prefix and vice versa process in a manual way. So pen and paper method, we've discussed that. And we've already talked about what is infix, what is prefix, what is postfix, what is stack data structure and so on. So if you have any confusion of all these different topics, do check out this entire DSA course, DSA playlist. I'll drop the link in the video description. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so if you watched the previous tutorial, which was postfix to infix conversion using stack data structure, and if you observe the rules right now, pretty much exactly the same rules that were there in postfix to infix are applicable in prefix to infix with two minor changes, and we'll talk about that. But for that, obviously you need to know postfix to infix. If you don't know, that's okay, we're going to discuss this thoroughly from scratch. But before we get on to the stack conversion, that is prefix to infix using stack, let's actually see this question and convert it manually. So over here you can see question number 1, convert prefix to infix, and this is basically using stack. Okay, so we are using this question throughout all these different tutorials because this expression is complex enough to cover all the different scenarios and all the different conditions. So let's see the manual conversion first. Okay, so here we have the question of prefix to infix in manual method. So this is a prefix expression, and I hope you know what is prefix. Prefix is when the operator comes before the two different operands, and we are talking about binary operators, which means operators operating on two operands. Okay, so over here plus is over here and a and b is over here, which means in the infix format plus should come in between these two operands. Okay, so this is basic, we've already discussed this, you all should know this. But anyways, when we convert this prefix expression in yellow to its appropriate infix format, this is how we progress, So first this plus ab will be converted to its appropriate infix format, and this raised to ef will be converted to its appropriate infix format. Then we will assume both of them as x1 and x2. So this is how the expression would look like. Then minus x1c will be converted and raised to dx2 will be converted to its appropriate infix format. Again we will assume them as x3 and x4. So this is what we get. Then star will come between x3 and x4, and that would result in x3 star x4. We will assume that as x5, and we will get this, that is divide by xy and g. So only two operands left with one operator divide by. So we will take that in between, and this is how you get the solution from here, which would be x5 divided by g. This is the final answer. And when we actually resubstitute these temporary variables of x5, x3, x4, x2 and x1, so after resubstituting x5 we will get this result. x5 is x3 star x4, right? So x3 star x4 in brackets, then divide by g. Then we will resubstitute x3 and x4's value, we will get this and this, and ultimately we will get the final answer, which would look something like this. Okay, now there are a lot of brackets over here, and if you're wondering why we have so many brackets, it is because in infix format the brackets play an important role because they decide which part of the expression is evaluated first. Because in infix we have a confusion, right? In infix we do not know which part of the expression has to be evaluated first, and that's why we have the operator precedence and associativity rules. So that's why we are using brackets to demonstrate which part or which sub-expression is evaluated first in the infix format, and that problem does not happen in prefix or postfix. In prefix and postfix we do not need brackets, we do not have operator precedence, we do not have associativity. Now I am reiterating all this, but we've extensively discussed all this in previous tutorials, so I'm not gonna waste a lot of time over here. But ultimately this is the final answer when we manually convert this expression. Okay, so this is the same expression that we have over here also when it comes to stack conversion. So if you observe, this is the same question which is over here, right? Let me just erase these markings and you can see it's the same question. So what we'll do, we'll take this entire result and write it over here. So this is the result that we get from the manual conversion, and now we are going to solve this same prefix expression and convert it to infix using stack data structure and then see if we are getting the same result. So this is something that we've done in previous tutorials also, just to make sure we are doing or applying the rules and the pseudocode in appropriate way. So now let's actually see the pseudocode. Okay, so this is the pseudocode of prefix to infix in the very center in blue color. On the left hand side we have rules for prefix to infix using stack. So the rules as well as the pseudocode are pretty much one and the same thing. It is just two different representations, and the reason why we have a pseudocode is because it gets easier to convert a pseudocode into any programming code. Okay, so pseudocode is language agnostic, which means that it is independent of any language, which means this same pseudocode will work on pretty much any other general purpose programming language. Only the syntax will vary, only the syntax will differ. So that's the beauty of pseudocode. The rules are pretty much basic English statements which state what happens in the conversion. However, it is not very easy to take these rules and directly convert them in code. That's why we have pseudocode. So basically both of them are one and the same thing. If you've seen the postfix to infix conversion, the rules are pretty much exactly the same with only two basic differences. So for those who've already watched that, the two differences are point number 1. So step number 1 over here is reverse the prefix expression or scan the prefix expression from right to left. That is, from the last element to the first element in this order. Or you can completely reverse this string, reverse this expression when it comes to coding using reverse functions. Or if you're going to go in the reverse order, you can use a for loop which starts from the end of the string, end of the expression, and go backwards. Okay, so programmatically this is what it means: reverse the prefix expression or scan the prefix expression from right to left. So this is one difference. And the second difference is in the pseudocode, where you create that intermediate expression, that is infix expression, which had the entire expression using op1, op2 and the prefix of I, which is gonna be the actual operator. Okay, so in postfix we had op2 and op1, but over here it is op1 and op2 because we are scanning the entire expression in reverse order. So this also interchanges the position, and you'll obviously understand when we actually dry run this entire pseudocode on our example. Right now I'm just saying it for those who already watched the previous video of postfix to infix. If you haven't watched it, this might not make sense, but let's actually take this pseudocode, go step by step, dry run this pseudocode onto our prefix example, and simultaneously we will also see the corresponding rule for that particular pseudocode. Okay, because as I mentioned, the rules and pseudocode are pretty much two separate or two different representations of the same thing. So every rule will have its appropriate line of pseudocode over here and vice versa. So starting off, this pseudocode is basically a function which is saying prefix to infix, which takes a prefix string, and at the end you can see it returns s.top, which is actually gonna be a complete infix string. Okay, let's see how we get till step number 3. So first step is to create a stack data structure. So we say stack s. So obviously when we write a code, we will create a stack, right? So this is that stack. Let's assume that this is that entire stack. Now second point or second step is to loop from I equals to prefix.length -1 to 0. Now when we are applying the pseudocode programmatically, this entire prefix string is basically gonna be kind of like an array, right? Because each character in this string will have an index position. So this is how it would look like, right? The first character in this prefix string will be at index position 0 and the last character will be at index position 12. So the size of the array is actually 13, or size of this string basically is 13. So the loop says prefix.length. The length of this prefix string is 13, -1 is going to be 12, right? And you can see we've written 2 0. So we will go from 12 to 0. So basically what we are doing is we are going to start from the end, that is index position 12, and we will go till the start, that is index position 0. So from 12 to 0. Okay. So prefix.length -1 will give us the last index position of the string, and it might vary, right? That is obviously the length of the prefix string will change depending upon the expression. Right now we are taking this expression, so the length is, that is the size is 13, hence we are starting from index position 12 and we will go till 0 in reverse way. So this corresponds to rule number 1, that is reverse the prefix string or scan the prefix string from left to right. We are basically using this type because we can either use reverse the prefix string or we can scan from right to left. So we are going with the right to left methodology. you can also go ahead by reversing the prefix expression, and when you reverse the prefix expression, in that case the loop has to go from 0 to 12, which means from left to right. Okay, so keep that in mind. Okay, so let's move inside this. We have 2.1 and 2.2. so in the loop we have one if and one else if. Okay, which means we have two subparts which can happen one at a time. And what are those subparts? It says if prefix of I, that is the symbol that we are scanning currently from right to left, if it is an operand, then you have to push it onto the stack. You can see s.push prefix of I. Else if it is an operator, we have to create op1, that is operand 1. We have to take it from s.top, that is stack of top. Then we have to pop that top. Then we have to take operand 2, which is going to be the new stack of top, store it in op2, remove that as well. Then form this expression, which is going to be an infix expression, because we will have prefix of I, which is the operator in between op1, that is operand 1 and operand 2, and push it onto the stack. So we have two major conditions. I know things are a little vague right now. We still have to dry run this onto our example. I'm just going through this pseudocode quickly, but overall, if you observe our prefix string, we do not have brackets. We do not have opening and closing brackets. So the only two possible cases of the character, that is the only two things that the character can be, is either a operand. A operand is variables, a comma b, or it can also be constants 1, 2, 3, or it can be sub expressions. A plus b entirely can also be a operand. So imagine a plus b star c minus d. So for this star operator, the two operands are a plus b is op1 and c minus b is op2. So for this star operator, this is one complete operand. So this also can be an operand, right? So this is one scenario. And the second scenario is obviously, if it is not an operand, then it is going to be an operator. What is an operator? Operator is plus, minus, divide by, star, that is multiplication, and raise to. In our case, we are only considering these five as operators. So only two things can happen, that is the symbol can be either an operand or it can be an operator. So that's why we have only two conditions. Okay. So if it is an operand, we have to simply push it onto the stack. If it is an operator, we have to pop two operands from the stack, put the operator in between, add opening and closing brackets, because in an infix expression brackets are important. That's why we add these extra opening and closing brackets. And then you again push that entire sub expression, that is sub infix expression that you formed, you push it back into the stack. So again, this is pretty similar to postfix to infix. If you watch that, things are going to be much faster and easier to understand. But now let's actually dry run this entire pseudocode, because that's how we actually understand exactly what is happening in the stack and how we get the entire infix expression from this prefix expression. Okay, so first things first, we create this stack. Step number 1 is done. At step number 2, we are going to loop from prefix.length minus 1, which is 12, to 0. Okay, so we will start from index position 12. At index position 12, we check if prefix of I is an operand. What is prefix of I right now? It is G. G is an operand, right? So for operands, you can see 2.1 will be executed. 2.1 says if prefix of I is operand, then we go inside and we have 2.1.1 which says s.push prefix of I. Now if you see the corresponding rule for this 2.1 point, you can see it is over here. That is point number 2 or rule number 2. If the incoming symbol is an operand, push it onto the stack. Simple enough. For 2.2, that is when the prefix of I is an operator, in that case we have rule number 3 which says if incoming symbol is an operator, pop two operands from the stack, add the incoming operator in between the two operands, add opening and closing brackets to the whole expression, and push this whole expression back into the stack. So all these 6 steps exactly do all these things that the rules have mentioned. Okay. And rule number 4 basically corresponds to point number 3 in the pseudocode, that is return s.top, which says at the end pop and print the full infix expression from the stack. Okay. So all the rules and the pseudocode is pretty much similar to each other and all of them are covered individually. But anyways, continuing with 2.1.1, we say s.push. So now G is going to be pushed into the stack. So this G is the new top of the stack. Okay. Since this if block is executed, obviously the else if will not be executed. So that's how programmatically if and else works, right? So either 2.1 will be executed or 2.2 will be executed depending upon what is prefix of I. If prefix of I is operand, obviously 2.1 will go. If prefix of I is an operator, obviously 2.2 will be executed. So for now 2.1.1 is executed, and then we will come at the end of the loop. Since 2.1 is executed, after this we will directly come at the end of the loop. We will go at the start of the loop, and now I will become 11. Okay, so I was initially 12, we were at end. So let's track I over here. I will now become 11. So we are at this index position. Now what is at index position 11? It is F. So F is also an operand, so we will directly push it onto the stack. Now this becomes the new top of the stack. Right? Again 2.1 is executed, 2.1.1 is executed. We will come at the end of the loop. I will now become 10. So we will be at index position 10. It is E. E is again an operand, again pushed onto the stack. E is new top of the stack. Again we move forward. I now becomes 9. So we are at this index position. So prefix of I, that is prefix of 9, now is an operator. You can see it is a raise to sign. So in that case, when it is a raise to sign, it is not an operand. So 2.1 will not be executed. We will go to 2.2. We say else if prefix of I is an operator. Yes, it is an operator. Step number 1 inside 2.2 is 2.2.1, which says op1 is equal to s dot top. So we will create op1, which is going to be equal to s dot top. What is currently at the top of the stack? It is E. So let me write E over here. Okay. Then we go at step number 2.2.2. We say s dot pop. When we say s dot pop, we simply mean that we remove the top of the stack. So E is thrown outside the stack. So let me just erase this out. And now the new top of the stack is obviously F, right? So now again moving forward at 2.2.3, we say op2 is equal to s dot top. Let's create op2. I'm gonna write op2. What is op2? op2 is s dot top, which is the new current top of the stack. It is F. So I'm gonna write F over here. We move forward, we go to 2.2.4, we say s dot pop. So again we remove F from the top of the stack. The new top of the stack now becomes G. Okay. Now we go to 2.2.5, we say exp is equal to, so let me write exp over here, equal to, we have opening brackets, so we have opening brackets as it is. Then we say plus op1. What is op1 over here? op1 is E, remember? So let's write E over here in the exp, that is in the expression. Then again we have plus prefix of I. What is prefix of I? Currently we are at raise to sign. So let's write raise to. Then we have plus op2. op2 is F. So let's write F. Then we have a closing bracket. So let's write closing bracket. And this is the infix sub expression which is formed using these three symbols from the prefix string. Okay, we formed a infix string using these three symbols. We took the raise to sign in between them. So we've got that. And when we move forward, if you see at step number 2.2.6, which says s dot push this expression into the stack. So we will take this same expression that we've just formed and we will simply push it onto the stack. So now this is going to be the new top of the stack. Okay, so this was 2.2, which means whenever we get prefix of I as an operator, all these things happen and we create a small infix sub expression and push it onto the stack. Let's move forward. Now obviously at the end of 2.2.6 we will come outside the loop and I will now become 8. So we are at index position 8 now. At 8 we have D. D is an operand. Let's quickly push it onto the stack because when it is an operand we simply push it onto the stack. So D becomes new top of the stack. Then I becomes 7. We are at this index position and again it is a raise to operator. So this time 2.2 will be executed. In 2.2 we have 2.2.1, we create op1. So I'm gonna write op1 over here. It is gonna be top of the stack. What is top of the stack? Currently it is D. So this is done. Then we move to 2.2.2, we say s dot pop, which means we remove this D from the top of the stack. So the new top of the stack is this sub infix expression, right? Then we say 2.2.3 is op2. Let's create op2 and it is going to be equal to s dot top, which is this sub expression only. So let's write that sub expression over here. Then we say 2.2.4, we say s dot pop, again remove this top of the stack. So the new top of the stack is G. Now we take these two operands. At 2.2.5 we create a new expression. We say exp is equal to op1. op1 is D, but before op1 we have an opening bracket. So let's use another color. Opening bracket. Then we have D. D is op1, you can see. After that we have prefix of I. What is prefix of I? It is a raised to sign. So let me write raised to over here. So this is done. After that we have OP2. What is OP2? OP2 is this sub expression. So I'm gonna write this sub expression over here as it is. And lastly we have a closing sign or closing symbol. So one more closing symbol, and this is the new expression formed, which we will take and push it onto the stack, because 2.2.6 says so. S dot push this expression onto the stack, and now this becomes the new top of the stack. So this is the new top of the stack, and you can see slowly our infix sub expression is building up. So this is an infix expression, and we've used so far these characters, these symbols, and converted these prefix formats into infix format. Okay, so now at the end of 2.2.6, again 2.2 is done, so we will go at the start of the loop and I will now become 6. So we will come over here. At index position 6 we have C. C is the operand. Simply push the operand onto the stack. If it is operand, we have to simply push it, right? This is the new top of the stack. Now similarly, if you observe 5 and 4, both of them are also operands. So obviously they are directly gonna go onto the stack. So let's skip those steps. Let me just directly push them onto the stack. Okay, so I've directly pushed C, B and A onto the stack. Those are operands. And now we will be at index position 3. So I will become 3. And now we have a plus sign. So when we have a plus sign, what do we have to do? We have to follow 2.2. 2.2 says create OP1 by S dot top. What is S dot top right now? It is A. So let's write A over here and remove that top. So A is removed from the stack. So currently the top of the stack is B. So this is done. Then we say S dot pop. A is removed. Then we say 2.2.3. We create OP2. OP2 is again S dot top, which is going to be B. And then B is also removed. So this is also done. Let's remove B from top of the stack. So what is currently top of the stack? It is C. At 2.2.5 we form this expression. We say exp is equal to opening bracket. Let's write opening bracket. Then we have OP1. What is OP1? OP1 is A. Then we have prefix of I. What is prefix of I currently? It is plus sign. So let me write plus over here. Then we have OP2. What is OP2? OP2 is B. And then we have an extra closing bracket, which is this one. So we formed the exp, that is the expression. Simply take this expression and push it onto the stack. That's how you do it. This becomes the new top of the stack. So this is also done. 2.2.6. We come at the end of the else if, that is end of 2.2. We come at end of the loop. I now becomes 2. So when I becomes 2, we again get minus. So minus is again an operator. So obviously again we have to follow 2.2. That is this else if part. We say OP1 is equal to S dot top, which is A plus B right now. So I'm going to write A plus B over here. Then we remove this top of the stack at 2.2.2. So the new top of the stack is C. Then at 2.2.3 we say OP2 is equal to S dot top. OP2 is C because S dot top is C. We again remove this C at 2.2.4. At 2.2.5 we create this expression. We say opening brackets. Then OP1. What is OP1? OP1 is opening brackets A plus B closing brackets. So I'm gonna write it as it is. Then we're gonna say prefix of I. What is prefix of I? Prefix of I is minus. So let's write minus. And then we have OP2. What is OP2? It is C. So let's write C. And then we have lastly a closing bracket. So this new exp is gonna be pushed onto the stack at 2.2.6. So take this expression, push it onto the stack, and this becomes the new top of the stack now. And you can see how slowly the sub infix expressions are slowly getting built up. So after 2.2.6, obviously we will come at the end of the loop. I will now become 1. And again at index position 1 we have a star operator, which is again a multiplication operator. So again 2.2. So again 2.2 is going to be executed, all these 6 steps. So let's do that. So in 2.2.1 we say OP1 is equal to S dot top. What is S dot top? S dot top is this current infix expression. So let's write that in OP1. Let me just take this entire OP1, OP2 and the expression formation on over here, okay? Because we don't have enough space over there. So we remove this top of the stack by putting it in OP1. Now the new top of the stack is this expression. So that is stored in OP2. So let me write OP2 over here. And let's take this expression and put it in OP2. Then at 2.2.4 we again pop that out as well. So the only thing remaining in the stack is G. So now how the expression is going to be formed, the expression exp is going to be equal to, at step number 2.2.5 we say opening brackets. So opening brackets, then we have op1. So let's copy this and paste it. We have op1. It's going a little outside, but I hope you're getting it. Then we have prefix of I. What is prefix of I? Prefix of I is a star operator. We are at I equal to 1. So prefix of 1 is star operator. So let's write star. Okay. Then we have op2. What is op2? op2 is this sub expression. Let's take this and paste it over here. And lastly we have one extra closing bracket. So let's add that closing bracket. Okay, there you go. And then at 2.2.6 this expression is pushed onto the stack. So let me write a minified version of it quickly. Okay, so this is that entire expression. I've compressed it and put it into the stack, because at 2.2.6 we push this expression onto the stack and this now becomes the top of the stack. So after this obviously we come at the end of the loop. I now becomes 0. We are at the very first element in the prefix string, basically at the last, which means that we have done pretty much scanning. So the last symbol obviously is again an operator. So again 2.2 will be executed. We say op1. op1 now is going to be this entire expression. So let's store it in op1. So at 2.2.1 we say op1 s.top. After that we say 2.2.2 s.pop. So we remove this top of the stack. Now the top of the stack is this single element G. Then we say 2.2.3 op2 is equal to s.top, which is G now. We remove that as well from the top of the stack at 2.2.4. Stack is basically empty. 2.2.5 say create this expression using op1 and op2. So the expression, let me write it over here, exp becomes opening brackets. So first thing is opening brackets. Then we have op1. What is op1? op1 is this entire expression. You can see over here also. Then we have prefix of I. What is prefix of I? Prefix of I is this divide by operator now, right? So let's write that over here, divide by written. Then we have op2. What is op2? op2 is G. And then we have one last closing bracket. And now at 2.2.6 we push this entire infix expression which is formed back into the stack. So this goes back into the stack. This is going to be the top of the stack. And then we will end this loop because I has become 0 and we are running this loop from 12 to 0 only. So the loop has finally stopped. After this loop, it is step number 3 which says return s.top. So this entire expression over here is at the top of the stack. It is returned and this is actually going to be the final answer. Okay. And this corresponds to rule number 4, that is at the end pop and print the full infix expression from the stack, which is gonna be at the top of the stack. And this, my friends, is basically the final answer. And if you just cross check this result with the manual conversion result, it is gonna be exactly same, which means that we've pretty much successfully applied prefix to infix conversion using stack data structure and applied the rules and pseudocode correctly. So I hope you've understood the entire process of prefix to infix conversion using stack data structure. We've understood the rules and the pseudocode. We took an example and applied the pseudocode onto that example. For better clarity, you can take other examples, simple examples, and apply the same pseudocode as well. Make sure you note these rules and pseudocode down. We are going to use this pseudocode in the next tutorial to write a C++ program to implement this prefix to infix conversion using a stack data structure. And obviously I'm going to be sharing all the details like these rules, the pseudocode, the actual C++ code with you guys on our official website, so you can check the link in the video description. So if you like this video, if you understood it, please give this video a like, do share it with your friends. Definitely let me know in the comments how this video was. Subscribe if you haven't already, because we have a lot of tech educational content on this channel. And I'll see you guys in the next video. Peace.